All right, let's jump right into it today. We're going to do a lot of hands-on kind of stuff where I'm going to have you try out some calculations. I'm going to check your work, see how well you can do. We're going to try out where you can actually make your own problems today. I know it seems a little weird, but I'm going to have you make your own problem, but I'll give you certain stipulations of what I want to see. And then I want to see if you can type certain things in your calculator and you know what to do. So the goal today, if you're not aware of what we started last Friday, we started section 8.4. This is the last section of chapter 8 that I wanted to cover. It's based on trig functions, trigonometric functions. Now, if you're not familiar with that, the trigonometric functions are certain formulas and geometry and trigonometry, which we talked about on Friday. The definition of trigonometry is the study of triangles. We basically focus on the study of right triangles for trigonometry. But the goal is that there's three main trig functions that you should see that are very familiar to you on your scientific calculator. So if you're not aware of that, if you look at your calculator right now, there's a sin, cos, and tan button. Okay, what those stand for? Those stand for the main trig functions. There's three main ones. Now there is three other ones. They're called the reciprocal functions. But your three main trig functions, which I'll abbreviate, are sine, cosine, and tangent. Sine, cosine, and tangent. A little crazy with the C there. Tangent. Now again, how they put these buttons in a calculator, they just use the first three letters. So SIN, COS, and TAN. You'll see them usually on a scientific calculator. They're usually like right next to each other. I think we started this Friday, but does anyone not see those buttons on your calculator? The sin, cos, and tan button, or sine, cos, and tan. Is that me?
Miss Vansicle wants a ruler and some toy tractors.
Called it. He did. Oh, it's like.
And the magic word? Oh.
And then you.
Tell her to keep these the rest of the day so I don't have interruptions all day like a Friday. Every video recorded Friday, somebody walked in. Every single period.
That's annoying.
Alright. Okay. So, sin, cos, and tan, these are our main three trig functions. The goal today, review what we did Friday, and then introduce new ones. Question?
Did you say you were going to lock the door that kept coming?
Oh yeah, I was going to do that. Totally forgot about it. I didn't do it. And they came in every period. I lost it at one point. I snapped at somebody. God, who was it? Who came in? Felt bad too. I was doing Gaelic. I snapped at her. Ooh, I felt bad. But she didn't know. Alright. But these three trig functions, these are our main ones. Now, what we use these for, have very distinct purposes. They're only used in right triangles, so keep that in mind. These are for right triangles. So if you do not have a right triangle, you should not be using these. Now, there is a way to cheat it, which we'll learn in like Algebra 2 and Pre-Calc. But as of right now, there's no way you should be using these outside of a right triangle. Okay? Because you haven't learned that stuff yet, how to manipulate them so you can use them for other types of triangles, which they call oblique triangles, triangles that are not right. Okay, but let's kind of go through this day. There was a little acronym we used on Friday, which was called SOHCAHTOA. Okay, it's called SOHCAHTOA. Those are your main three little acronyms that we use to remember the formulas that we have. Now, the letters, there's capital letters out front like we talked about Friday. There's an S, C, and a T. Obviously, you can probably figure out they'll stand for these. The little lowercase letters after it are the actual formula. So there's an O and an H in the front. There's an A and an H, and then an O and an A. So those are the letters if you can't see it from where you're sitting. I know my penmanship isn't the greatest, but the goal today is to kind of figure out what they are, because we talked about, I think, the first one on Friday. We just did sine. We'll review that one here. We'll do an example or two of it. But then we're going to learn the other two today, and I want to try to get to a point today where you guys can make up your own problem, where you can make your own little story problem that's involved, and then you have to figure out which one of the three to use for your particular problem. which is unique because every problem could require one of them. It's not always the same one. It depends on what your story problem involves, like what you're looking for. I know these are kind of far-fetched, but it gives you an idea like what we can actually use it for. To give you an idea of this, my grandfather, I think he only took through 8th grade math when he was in school. He was very, very old, but he worked for carpentry, wood for Wheeler and Clear Lake. He knew how to use the buttons on the calculator, but he didn't actually know what he was doing because he only had 8th grade math. That's the education he went through. But he was really good at it. Like when he saw me doing my homework when I was in school, when I was in high school, kind of doing the same thing you guys are, geometry, he immediately knew what I was doing. He didn't know what it stood for, but he knew how to type it in his little calculator that he had, and he could get the same answers as me. Because what he used this for is to build A-frames for housing, so because he did construction. But it was really impressive to see my grandfather, who was like 89 at the time, actually doing it. He didn't know like what the actual button stood for. He didn't know these 3 words, but he knew how to type it in a certain way on his calculator that always gave him the answer he was looking for, so that he knew like how to measure it with a tape measure, which I was really impressed by because he didn't have the formal training like I've had or you guys are getting. He just he was taught on the job site and then he just knew what to do. But I thought it was really cool that he could do basic trigonometry, which is way above the level of an 8th grade math student. But anyways. Let's talk about these. So sine, cosine, and tangent. So we're going to start with the first one. The first one, the S, stands for sine. That's the sine function. Now, the formula that's involved here, what we talked about on Friday, was that you use the lowercase letters in the back to actually set up your formula for a right triangle. Now, I'm going to give you the formula first, then we'll go to the picture here in a second. So what this stands for, it stands for sine of an angle. So when you actually hit the little sine button on your calculator, it's waiting for you to type an angle after it. That's why there's always on my type of calculators, like these numbers. On this type of calculator, it's called a menu-driven calculator. When you type sine, there's always a parenthesis after it, because it's waiting for you to type an angle. Okay? On non-menu-driven calculators, like Dalton, hold yours up. So, on that one, that's a different style of calculator. It's not menu-driven. It just does his calculations as he types it. So for Dalton there, he has to type in the angle first, then hit the sine button, because it will actually calculate that for him. So that's the same way that your cell phones work, because your cell phone can actually do the trig functions. You turn your phone sideways, it gives you all the trig functions on the scientific calculator. The only problem with that is that I found some Android phones, are not set up for degrees. You can't type in the degree angle, which I think is really, really weird. They're set up for radians, which you can change in the menus on an Android calculator. But on an iPhone, I think it's always set to degree. As long as and again, on the iPhone, you can always download other programs that will make it work as the App Store and stuff, same with Android. But I always find that funny. So just be careful if you're using your cell phone a lot. Make sure it's giving you the correct answer. So compare it with an actual calculator to make sure that it is in the correct mode. I'll explain that here in a minute. But the sine function is equal to, so sine of an angle, is equal to these 2 letters. The second letter is on the top. Third letter is actually on the bottom. So what I mean by that is that the O is the top letter of my fraction. That stands for the opposite side. That's what the O stands for. And then the H goes on the bottom of the fraction. That stands for the hypotenuse. There we go. Okay. And this applies to a right triangle. So wherever your angle's at in the triangle, you have to look at the opposite wall for that angle, and then the hypotenuse itself. And what your calculator actually has is the memory is stored with all the combinations of triangles that you have, so that it knows, like, when you type a certain angle in there, it knows what the triangle should be. The walls, those 2 walls are in a relationship to each other. It's guaranteed on a right triangle. It's like set. Like it's so rigid, they're not going to change. They're in a certain relationship to each other. That's why it's actually really useful, the way that these are actually stored. But again, in your right triangle, the angle just has to be in a certain spot. It doesn't matter if it's top or bottom, but wherever you put your theta, your angle that's in question, then from there you can put the opposite wall and the hypotenuse. The hypotenuse should always be the same wall. You should know where the hypotenuse is at, right? It's the longest wall, it's the wall that doesn't touch the 90. But the opposite side is the one across the picture from your angle. So this would be the opposite side. Now again, if you move that angle to the top, so if you put this angle, whatever angle you're in question, at the top, now this is the opposite wall. So it depends on your story problem where you put the opposite wall at. So maybe on this particular case, you want to find the height of the building, or the height of an object. But you have, the ladder going to the top, or a cable going to the top, and the angle that the cable's making with the ground. Okay, so let me do a really far-fetched story here. Let's say that we're going to figure out the height of a hot air balloon up in the air. So here's your little car. They call it a car, the basket that you sit in. Here's your little hot air balloon. There it is. You can put a star in it. There's your hot air balloon. All right, and this is the rope that it's on, but let's say it's a 200-foot rope. Okay, so they're doing hot air balloon rides at the carnival, right? So there's a 200-foot rope connected to a hot air balloon. And like we talked about Friday, you can use your cell phone to actually figure out the angle to objects. You don't have to just eyeball it. You just, on the phone itself, I showed you this on Friday, that every, major smartphone, they have a compass app. So if you open up the compass app, it usually tells you where north is. You have to program it the first time. You have to wobble your phone around until it programs. But when you swipe to the side, it tells you your angle. That's called a level, right? That you can tilt your phone, it tells you the angle you're tilting at. Well, if you put it on the ground and you tap the screen, it levels it back to 0. And then you just set your phone on the rope and it tells you the angle the rope's at. So the rope's at 42 degrees, let's say. I'll put that on my picture here. So maybe it's a 42-degree angle to the top of that rope. Okay, 42 degrees. And I want to know how high is it off the ground, the altitude of my actual hot air balloon. That's a really great problem for this. Now, the other thing I could do, I could figure out, maybe I have the altitude of the balloon, maybe I want to know how long of a rope I would need to be holding on to. That could be another type of problem, but it has to be these three numbers. It has to be an angle, the opposite wall, and a hypotenuse. One of the three numbers could be missing, I don't really care which one. But it should give you the idea. So let's set up these numbers in my actual formula. So my angle is 42 degrees, so sine of 42 is the opposite wall over hypotenuse, and the hypotenuse is the 200. That's how I set up my formula. Now, what I'm actually going to type in my calculator, because the calculator will just spit out an answer, we have to get the x by itself. So since the x is on the top, and they're dividing by 200, what's the opposite of dividing by 200? Multiply. So you take 200 times the sine of 42. That's how you do it in this case, so it would give you your answer. So I'd like you to turn on your calculator real quick. Before we start typing this in, because I know a lot of you are really good at this already, but before you start typing this in, make sure somewhere on your screen, on your calculator, that it says DEG. Somewhere. It's really small print, it's usually on the screen somewhere, or it has like a little capital D in like a box. That means it's in degree mode. If you don't have that, let me know. If you don't have a little DEG, like the things I'm worried about, if it has RAD, like rad, or English, or fix, or something like that on the screen, we need to be worried, because that's in like a scientific mode for chemistry and physics. They have it programmed so that only certain decimal places will show. That's one thing I'm kind of worried about. Is everyone good to have the little DEG on the screen, like degrees? That's what it stands for. Okay, if you have that, you can type it in exactly how I have written it right here. So most of you in here can type it in 200 sine 42, then hit the equal button. Now, for those select few that don't, like Dalton, where was another one that I saw? Curly, you have to type it in backwards. So you type the 42 first, hit the sine, then type 2, then take it times 200. Same with Jade, you have to do the same thing. I think everyone else's calculator is basically the same. What are the numbers we're getting now?
133.
133? Okay. 133 point what?
82.
82. Okay, and this would be in terms of what, feet? Okay. So you're about 130 feet off the ground. Okay. Did anyone not get 132 when you typed that in the calculator? Or 133? Did anyone not get it for sure? Like everyone is getting the right answer, is the correct number that everyone is there anyone that doesn't know how to type it in? Because I mean this is the first second day of this. Okay. So on yours, I think you have to find on your trig functions, I think they're under trig functions. So you have to hit the little second key and then hit the trig function. and then scroll down, or yeah, hit 1, there you go, and then type in 42. So yeah, so you have to hit, like, type your number, shift, and then trig functions, and then they show up. Nice.
So that number is how tall it is?
Yeah, that's how high it is off the ground. So the higher balloon right now is currently sitting at an altitude of 130 feet off the ground. So that's the idea. So this is the number we get now. That's I know that seems silly, but that's kind of the idea that you can do to figure out heights of airplanes and stuff. In fact, most cell phones now, especially like with the iPhone and stuff, you can just ask the assistant program. I'm not going to say her name. To tell you all the airplanes that are above you currently. And she'll say all the altitudes, all the planes, where they're heading, their directions that they're going. And so like just knowing like how high they are off the ground, or the direction they're going, you can figure out the distance to those objects, how fast they're traveling, all that good stuff. It's actually pretty impressive, the stuff you can do. And this is like the start of it. That you can do, certain things, because you can always set up things in triangles and actually find lengths of them, as long as they're right triangles. Now, a different style story problem with this is maybe, I'm going to try to stick with the sine function. Maybe a different style story problem completely that would take a different result, a different way to type it in, but still use the sine function. Maybe you're in, let's just redraw. I'm just going to restart here. Let's say you're in this really terrible looking airplane. So here's my little airplane. Looks like a jet. There you go. There's your little jet. All right, and you're gonna come in for a landing at an airport. So here's your runway. Okay, and the idea is that maybe the angle here, which is they call it an angle of depression. Okay, this is an angle of depression where you're looking, straight ahead, but you look down. This angle of depression, let's say it's 12 degrees. That's where an airplane is like looking down at a runway. That's how far they're tilting the nose. And let's say that their altitude above the ground is, 10,000 feet. I want to know, how far do you have to travel to get to the runway itself? Okay. Well, this story problem wouldn't require sine. Right away, unless you know how to work with the 12 here, because that angle, what I said earlier, was an angle of depression, right? An angle of depression is looking down at an object, not looking up to the top. That 12 can go here. Now, why I know that? These walls are parallel, right? They, looking at the horizon and the ground should be perfectly parallel to each other. So the 12 can hopscotch in here. That's called an alternate interior. Now that I put the 12 on the inside, down here, now that's a sine function, the way that it's set up. Now how I know that is because I have my angle, this is my theta, this is the opposite wall, and this is the hypotenuse of my right triangle.
So why did the 12 go down there?
Because of the alternate interior, so it's based on two parallel lines. If you draw a transversal through them, these angles are the same. That's what we have. Because when the pilot is looking straight ahead, this 12 degrees can hopscotch inside the triangle because there's a line going through two parallels. A lot of people wouldn't see that. It's one of those things that a lot of people would never think about that you could do that. That's why, on the actual airplane itself has a little rotational ball for the accelerometer kind of thing, where it's actually tilting. It's actually telling you the angle you're tilting at, and there's numbers that are on it. Okay. Well, that's how a pilot can figure that. They can figure out, how to dive the nose of the plane through an angle of depression, because that's the same angle as looking up. And if you know your altitude, this can now tell you how far your runway is away by just knowing how far to tilt to look at that runway itself. And they can do a quick calculations. Now, obviously, pilots, if you're going to try to get your pilot's license, you actually have to know a lot of trig, a lot of trigonometry. In case all the instrumentation fails on the actual airplane itself and you have to actually land. They do require some extensive knowledge in trig, which is actually this stuff. It's a part of the test that you have to take. But anyways, I can actually figure out, the length or the actual distance to your runway, the actual air distance, not ground distance, but air distance. So how far you're going to fly till you can finally land. Where I'm going to plug these numbers in. They just go in the formula in these same spots. You have your angle, which is the 12. You have your opposite wall, which is the 10,000, and then the hypotenuse is missing. So this is a different style problem, but it will still be able to be solved using the sine function. Again, I know it's a little far-fetched, but sine of 12 degrees is equal to the opposite side, which is my 10,000 feet, so it's about 2 miles up, and then the hypotenuse is the one wall we're missing. How far is it to the runway? Not ground distance, but air distance. Now, what's weird about that setup versus my other problem? Yeah, on this one, the x on the bottom, not the number, like the 200 like we did in the last problem. This has the x on the bottom. That's a little weird. It's a different setup. So what we need to do, if there's an x on the bottom, not on the top. If it was on the top, you just multiply the number across. But since the x on the bottom, here's my little shortcut. You switch these two. You switch them. You get x off the bottom. You put the x over here, and you move the sine of 12 down. Now the reason why, because you'd actually multiply the x across. You'd actually multiply the x across because it's on the bottom. But you have to get x by itself, so this is being multiplied onto x. This is just a digit on your calculator, it's like a decimal. You'd have to divide that number over. So it's actually switching to be like this. And that's what you have to type in your calculator. Now, anyone that has a menu-driven calculator like mine or Ms. Nelson's here, this, you can type it in the 10,000 divide by sine 12, hit enter. If you have a calculator like Jay's or Dalton's or Carly over there, what I recommend for you guys, especially you three, since you have a weird type of calculator, figure out what the sine of 12 is first. So Jade, I'll have you type it in. Type in 12, hit the sine button, give me that decimal. Jade.
0.207.
0.07, okay, that's what this is.
207.
Oh, 207, jeez. 0.207, 207, okay. So that's the sine of 12. Now that you have that number written down, now just take 10,000 divided by that. So for you guys, you have to do it's almost a two-step problem. You have to figure out what the sine of 12 is, then you can divide by it. But everyone in the room should be getting the same number now, roughly. So what's the number we're roughly getting?
4,809.73.
4,800.
48,000.
Say it again?
48,097.34.
97.34. Okay. Do we get weird numbers? Did you not type in 10,000?
Yeah, I forgot a zero.
Yeah, that happens. That's another thing to check. Doesn't make sense. It had to be more than 10,000 feet because it's the hypotenuse we're looking for. That's a longer distance. 48,000. If you want to figure that in terms of miles, you divide roughly about 5,280. That's how you convert feet to miles. If I'm doing that, I don't know, maybe about 9 miles-ish, 8 miles-ish. That's ballparking my head before we start. I don't even have a calculator on me. Where's one? 48,000. 48,097.34 roughly. That's roughly the numbers divided by 5,280. Yeah, about 9 miles, 9.1 miles. So you get quite a ways. It's quite a distance to the actual runway still, so you can start your approach. Question?
May I go ahead and drink?
Yes. All right. Questions at all about the style of how the sine function works? Now I know these examples are very far-fetched. You can do other things with it, but typically you can use these to find heights or lengths of objects. An A-frame, if you're building for a house, you can figure out how long the boards need to be. That's what my grandfather did. If he knew that this board, was 10 feet, how long would the other board need to be, so that it made a perfect A-frame with a certain angle in the corner, because maybe they wanted the roof line a certain angle for it. That's what he used it for. So he knew that the board, 48,000 centimeters or something like that, whatever that number is. Okay, questions with the sine function. Now again, I know it's far-fetched, but do you see that there is a use for it though? It is actually practical versus some of the other things we do here. You can actually do quick calculations. That's why they're all put in a new calculator. I think it's pretty cool. But that's a new type of problem, right? We haven't seen something like that. All right, let's do the cosine function now. Let's do the cosine function. So the second one now, a brand new one today. The cosine function. Okay, so let's say, okay, this is going to be really weird. So we're going to go with the cosine function, so let's write this formula down. So this is the cosine function. That's the correct name, that's the correct spelling. I know it's weird, I usually don't write out the full names, but that's the full name of it. What this function stands for is cosine of an angle. So your calculator waits for you to type an angle. That's equal to, now what these letters stand for, the A and the H, these are the letters for the formula. The A goes on the top, because the second letter always goes on the top. That stands for the adjacent side. Adjacent means next to. And then the H is the hypotenuse, that goes on the bottom. The third letter always goes on the bottom. Okay, I'll let you write this down, then I'll give you kind of a weird, far-fetched story, but it is actually useful. You can actually figure that out. Okay. It's going to seem a little weird, but so let's say that you're trying to figure out how to get to the top of the building. I don't know why, but let's just go with it. So you're trying to figure out, maybe I want to figure out, how big is the ladder that would get you to the top of this building? Okay, that's what you're trying to find. This will say that. Okay. But you know how far you're standing from the building. Let's say you're standing, 15 feet from the building. 15 feet. And so you're standing right here, this is you. Okay. And we're not going to put your height in consideration. I know that you have a certain height that you're looking at, but we're not going to put that in consideration. But you're looking up to the top of the building. Now I do need kind of a bigger angle, but not 90. So
29.
say it again?
29.
29 degrees. Okay, so it's not a big angle, but you're looking at an angle of 29 degrees. Let's say you held your phone, in front of you, you leveled it, and then you look up at the top of the building, you kind of put it next to your eye, and you kind of eyeball the top, and you look at your phone and it says, oh, you're looking at a 29-degree angle. This is the type of problem that you could do to figure out the length of the ladder. I don't care about how tall the building is. I want to know, is there a ladder that I could buy that could get me to the top? Okay, I know that seems a little far-fetched, but we'll go. Okay. Now, I'm expecting, I'm trying to find the hypotenuse here. So this number is got to be the biggest wall. So it's got to be more than 15. So it's got to be kind of a bigger ladder. It's not a small ladder, 10-foot ladder, 6-foot ladder. It's got to be bigger than 15. This is the hypotenuse of a right triangle. Because if I label these, this is the hypotenuse. Okay, that's the hypotenuse. This wall now is the new one. This is the one I was talking about. This is the adjacent wall. What an adjacent wall is, or adjacent side, that's a wall that is right next to your angle. But it's not the hypotenuse. Because I know that the hypotenuse is always next to the angle as well. But it's the one wall that's one of the legs that's right next to the angle you're dealing with. So if your angle is up in the air, maybe you're up on the top of the building, the adjacent wall would be the actual height of the building. So if you're standing up here and you had the angle on the top, the adjacent wall would be the height of the building itself. So it's always the angle that's or the wall right next to your angle. So now if I plug these in, now this is going to use that little switcheroo thing like we did earlier because the x will be on the bottom. But cosine of my 29 degrees, that's the number we made up. The adjacent side is the 15 feet, that goes on the top, and the hypotenuse is the number that I'm missing. So since the x is on the bottom, what's my little switcheroo? What do we do?
Move the x over.
Yep, move the x over, and?
Cosine.
Yeah, move cosine over. Since the x is on the bottom, this is what you do. You always do your little switcheroo in case the x is on the bottom. If the x is not on the bottom, just multiply the number across. But on this one, so like on Carly, Jade, Dalton, you guys will have to figure out the cosine of 29 first. Write down your decimal. And then you have to take 15 divided by that. But everyone else in the room, you can pretty much type it exactly how you see it here. 15 divided by cosine 29. Hit enter. And I should be expecting a number bigger than 15. How big is my ladder? What do we have? What's my hypotenuse?
17.15.
17.15. Okay, and this would be in terms of feet. So maybe a 20-foot ladder would get me there, 17 feet. So 20 feet for sure will get me to the top of the building, so maybe it's a 2-story building. It's kind of a smaller building. My picture is not drawn to scale, obviously. Okay, questions at all about the cosine? Now, obviously, if the number was on the bottom, so maybe I gave you the hypotenuse, the ladder itself, this, you'd have, the hypotenuse would be on the bottom, you'd be finding the adjacent wall, maybe. Maybe you want to know how far you'd have to set it away from the building so you could set up so it reaches to the top, that type of thing. Okay, questions with the cosine function. It's basic same uses. You always use the hypotenuse, the ladder, the cable, the rope, whatever it is, the distance to the object itself. All right, questions? Perfect. Now, let's go through the last one. The last one is tangent. It is by far the most used formula out of them all. The most used. This is probably the most practical one I can give you. And I will give you probably a crazy far-fetched story with this one. So, all right. Okay, the last one, which is the tangent function. The last one here, tangent. Tangent function, which is, if you look at the letters here, tangent of an angle, so tan of your angle, is equal to, now the letters behind it is O and A. So O goes on the top, the second letter always goes on the top, so that's the opposite side. And the adjacent is on the bottom. Now I'm going to give you kind of a weird, far-fetched story, but give you the idea. Now my number is not going to be accurate. I'm just going to make up this problem, but this is something that our space program actually does to figure out distances to objects, other than using the red and blue shift of light spectrum to figure out distances. What original astronomers did was to figure out the actual distance to our moon. That they would hold up a ruler and kind of measure the actual diameter of the moon, and then they could figure out roughly the distance to a person on the Earth. So, and they did it with an extreme precision of they're actually extremely precise on the actual distance itself, because the actual diameter of the moon itself is actually incredibly small. Like when you hold up a measuring tool, it's not very big. But they had this number, which let's say in the sky it was maybe 2 inches. Maybe it was kind of a smaller moon that it wasn't the super moon, but it was kind of smaller for us. They knew the angle, from the bottom of the moon to the top of the moon. Let's say that was 3 degrees. Now what we can find is the actual distance to the object, not the hypotenuse, but the distance to the object, because this is what my triangle looks like. It's about 3 degrees. That's from the bottom of the moon to the top. We know that the moon itself is 2 inches, and they can figure out, the actual distance to the object.
Ooh.
Now again, this is not accurate. This just gives you an idea. NASA does something very, very similar to this to figure out distance to actual objects in space, because they're extremely precise, because they can use satellites, and the satellites itself can actually use artificial intelligence to figure out the height of an object correctly. They can actually scale it correctly, and then they can figure out the actual distance to the object. So this uses tangent. This is the opposite wall to my angle. It's the wall across the picture. This is the adjacent wall, and those are the numbers I plug into my picture. So tangent of 3 degrees is the opposite wall over the adjacent wall. And then we do our little switcheroo. Now again, this is not accurate, but this gives you an idea of like what they did. Original astronomers somehow figured out an extremely precise distance to the moon and the diameter to the moon, the actual true diameter of it, within a few feet. It was actually really impressive. And they did this all without calculators. So tables and numbers and pretty impressive stuff. But again, how you'd actually do this, you do your little switcheroo. So I'd take 2 divided by the tangent of 3. So 38. Again, this is not accurate, but you guys know. Okay, questions? Good. Okay.